Yeah. Can you hear me? Yes, I guess. Okay. Yeah, thank you very much. I hope you had a nice coffee break. So, dear ladies and gentlemen here in the room and also online, I'm delighted to represent our working group Post-Mining Exploitation from the Fraunhofer Research Institution for Energy Infrastructures and Geothermal Systems settled in Bochum. My name is Stefan Klein, and I'm a geologist working for the Fraunhofer IEG since 2020, together with my colleagues Florian Hahn and René Verhoeven, several of you might know. So today I'm going to present recent project updates and some feasibility study results concerning mine water energy and storage in Bochum. So I'll tell about the 5th generation district heating and cooling project status update of MARC 517 using mine water as a source, but also as a storage, a project of my colleagues Florian and René. I'll tell about my own research project, the European Push-It project, where we want to develop mine thermal energy storage on a larger scale. And furthermore, I want to give some recent first results from an ongoing study about the Bochum Central mine water drainage site. So to introduce to the topic, please have a glance on the post-mining map area of hard coal in central North Rhine-Westphalia in Germany. Here we have Bochum marked with the black circle. And Bochum is well known as a former famous city for hard coal production for many, many years. So this map has been recently published by our working group and categorizes the potential for mine water energy projects regarding to the mine water table and should emphasize on the low-hanging fruits, which are indeed the 7 mine water drainage sites marked by the stars, but also the areas in green where the mine water is available already in shallow depths. So, let's have a quick recap for those who haven't heard about the MARC 517 concept. So, the drilling of the 2 wells you can see here are part of the former Dunbaum colliery, and this is connected to 2 other mines as shown in the left picture. Almost 6 million cubic meters of mine water are flowing through these mines yearly and drained into the central Ruhr River. So the mine water level is at 230 meters below the ground level. The drilling work has been completed already in 2022, and both wells were drilled at a singular position. You can see at the right picture. So the cold well was drilled vertically, shown by the blue arrow, and is about 340 meters deep. The hot well is about 820 meters deep and was drilled directionally. So it was drilled in such a way that no galleries or coal seams has been crossed through the drill path. The innovative part of this project was actually the integration of a 3D borehole path model from the oil and gas industry combined and used in a thermal hydraulic model environment actually in the software Spring. So this was the innovative part during the or before the drillings could be realized, and the drillings have been realized successfully. So this is the current stages. MARC 517 will be mainly a so-called quaternary sector area, meaning business research and development with at least 3 decentralized energy stations here, here, and here. The first of those, the smallest one in the middle, called Demonstrator, has been already erected. The 2 remaining stations on the left and on the right are in the call for tenders currently and hopefully finished by end of next year. So together with the mine water heat exchange energy station, which is close to the boreholes, hopefully also will be erected by end of next year. The scope here was actually to establish the first 5th generation district heating and cooling grid in Germany, analog to the principles of Herlen in the Netherlands, with different demand-driven grid temperatures supplied by a common exchange grid, which you can see in the blue, as in the blue line. Between the different decentralized energy stations and the mine water as the primary heat source, if no surplus energy is available from the different decentralized energy stations. Or, meaning at least you have the exchange grid, and if there is not an appropriate amount of energy which is needed for the decentralized energy stations, the mine water plant will going to run, and so the rest of all the plants will be hopefully installed by end of next year. So now I want to give an update of our main research project, which is part of the Push It Consortium, an EU project started last year. Within this project, our aim is to further develop and test mine thermal energy storage in conjunction with the Ruhr University in Bochum. Here we want to drill into 2 former galleries, you can see on the right-hand side, as we did it similar within the Heatstop project, so again with our own institute rig, but here in a depth of 120 meters. So what we are going to expect? We expect 2 isolated and flooded former galleries, which were used as an underground factory before. So the interesting actually of this project is that directly above the former galleries, there is surplus heat from the university's cooling grid available. So yeah, it's a very nice project because in this case source, storage and sink are united at one demo site. So as you can see, the next step will be exploration drillings of 4 boreholes. So several in situ tests like we did it within the Heatstop project, and enhanced well completion with glass fiber reinforced epoxy casings together with Huisman, and at least hopefully a connection to the technical center, and to have a proof of concept that this can work. So, last but not least for today, our working group wants to give updates for the mine water drainage site in Bochum. So this is an example, as you have seen on the second slide, we have at least 7 drainage sites, but we also have one in Bochum, where for several years, unfortunately 10% of the total potential is used for the school and the fire department. This runs very successfully, but it's just 10% of the actual potential. The current idea of our feasibility study is to divide this project into different time-dependent design stages. The first, you can see here, foresees a direct use at the drainage site itself, like it is used for the school and the fire department settled in the close vicinity for some years. The second stage is the erection of a mine water exchange plant in the context of a larger energy supply, which is similar to Mark 51.7 indeed. And the third and the main design stage would be the construction of decentralized energy stations with heat pumps around the drainage sites, also similar to Mark 51.7. So currently we are calculating the levelized costs of energy together with our stakeholders for such a project. One of the first results is that only waste heat as a heat source would generate less levelized cost of heat. So as a key message for you today, if it will be decided to extend the urban heating grid in Bochum, the central drainage site is a competitive heat source for such decentralized energy stations. I want to close my talk with our motto from our working group. So, mine water heritage, from eternal burdens to eternal benefits. Thank you.